Welcome to this exploration of a truly fascinating mathematical coincidence. Today, we are going to learn a clever mental math trick, how to convert miles to kilometers using nothing but the Fibonacci sequence. By the end of this lesson, you will be able to explain why this trick works and use it to estimate distances on the fly without a calculator. Before we dive into the trick, we need to make sure we are comfortable with the Fibonacci sequence itself. It is one of the most famous patterns in mathematics. The rule is simple. You start with 0 and 1, and then every subsequent number is the sum of the previous two. We start here. 0 plus 1 is 1. 1 plus 1 is 2. 1 plus 2 is 3. 2 plus 3 is 5. 3 plus 5 is 8. As we continue, the numbers grow. Let's list a few more. 13, 21, 34, 55, 89, and 144. Take a moment to look at these numbers. They appear everywhere in nature, from the spirals of a sunflower to the scales of a pine cone. But today, we are interested in their relationship to distance. We have defined the Fibonacci sequence, which is the first step in mastering our conversion trick. Now, let's look at the actual conversion factor between miles and kilometers. 1 mile is approximately 1.609 kilometers. In the world of mathematics, there is a very famous number called the golden ratio, often represented by the Greek letter phi. The value of phi is approximately 1.618. Notice how close these two numbers are, 1.609 and 1.618. The difference is less than 1%. This proximity is the secret sauce of our trick. But what does the golden ratio have to do with the Fibonacci sequence? They're in a beautiful property of the Fibonacci sequence. As you go higher and higher in the sequence, the ratio of two successive numbers gets closer and closer to the golden ratio. 3 divided by 2 is 1.5. 5 divided by 3 is about 1.666. 8 divided by 5 is exactly 1.6. 13 divided by 8 is 1.625. 21 divided by 13 is approximately 1.615. Because the ratio of consecutive Fibonacci numbers is almost exactly the conversion factor from miles to kilometers, we can use the sequence to switch between the two units almost instantly. We have connected the conversion factor to the golden ratio and the Fibonacci sequence. Here is the core trick. To convert miles to kilometers, find the number of miles in the Fibonacci sequence, and the next number in the sequence is the approximate distance in kilometers. The Fibonacci sequence goes 1, 2, 3, 5, 8, 13, 21, 34, 55, 89, and so on. Let's try a simple one. Suppose you are running a 5-mile race. How many kilometers is that? Find 5 in our sequence. The next number is 8. So 5 miles is approximately 8 kilometers. If we check the math, 5 times 1.609 is 8.045. Our estimate of 8 is incredibly close. What if you have 8 miles? Find 8 in the sequence. The next number is 13. So 8 miles is roughly 13 kilometers. The actual value is 12.872. Again, the Fibonacci number 13 is a fantastic mental estimate. This works in reverse, too. To go from kilometers to miles, you just move one step backward in the sequence. If you see a sign for 21 kilometers, just look at the Fibonacci number before it, 13. 21 kilometers is about 13 miles. The calculation shows 13.05 miles. The trick is nearly perfect here. You have now performed basic conversions using consecutive Fibonacci numbers. But what happens if the number you want to convert isn't a Fibonacci number? Don't worry, the trick still works. We can use a property called Zeckendorf's theorem, which sounds fancy, but it just means every positive integer can be uniquely represented as a sum of non-consecutive Fibonacci numbers. Basically, we just break our number down into Fibonacci numbers that we do know. Let's say you want to convert 10 miles. 10 is not in our sequence. Here is the Fibonacci sequence: 1, 2, 3, 5, 8, 13, 21, and so on. We can write 10 as the sum of the largest Fibonacci numbers possible without going over. 10 equals 8 plus 2. 8 is a Fibonacci number, and 2 is a Fibonacci number. Now we apply the trick to each part separately. The number after 8 in the sequence is 13, so 8 miles becomes 13 kilometers. The number after 2 in the sequence is 3, so 2 miles becomes 3 kilometers. Now we just add those results together. 10 miles is approximately 16 kilometers. Look at that. 16 is almost exactly right, since 10 times 1.609 is 16.09. Take a moment. How would you break down 18? You could use 13 and 5. 13 plus 5 equals 18. 13 shifts to 21, and 5 shifts to 8. 21 plus 8 gives us 29 kilometers. The actual answer is 28.96. The trick is remarkably robust. You can now convert any number by decomposing it into Fibonacci parts. What if the numbers are very large? We can combine the Fibonacci trick with simple powers of 10 to handle any distance. Suppose you were looking at a cross-country trip of 400 miles. 400 isn't a Fibonacci number, and breaking it down into small parts might take a while. Instead, we can scale it. First, let's look at 40. We can decompose 40 into 34 plus 5 plus 1. Wait, 34 plus 5 is 39, so we need one more. 40 equals 34 plus 5 plus 1. Now, find the next Fibonacci number for each. 34 goes to 55, 5 goes to 8, and 1 goes to 2. 55 plus 8 plus 2 equals 65. So 40 miles is about 65 kilometers. Since we started with 400, we multiply our result by 10 to get 650 kilometers. Our estimate of 650 is within 1% of the actual value of 643.6. This is perfect for road trips or flight distances. You can also use the fact that the relationship is linear. This is another shortcut: doubling. If you know 50 miles is 5 times 10, and 5 miles is 8 kilometers, then 50 miles is 80 kilometers. If you need 100 miles, just double it, 160 kilometers. The actual value is 160.9. The Fibonacci sequence gives us a mental framework that is far more intuitive than trying to multiply by 1.609 in your head. You can now scale the Fibonacci trick to handle large distances by using powers of 10 and basic arithmetic. Let's refine our skills with a more complex, real-world scenario. Imagine you are looking at a marathon distance, which is approximately 26 miles. How would we convert this using our new mental toolkit? 26 is not a Fibonacci number. Let's look at our sequence again. Step 1. Decompose 26. The largest Fibonacci number less than 26 is 21. 26 equals 21 plus 5. Both 21 and 5 are Fibonacci numbers. This is a perfect decomposition. Step 2. Shift each number forward. The number following 21 is 34. The number following 5 is 8. Step 3. Sum the results. 34 plus 8 equals 42 kilometers. So 26 miles is approximately 42 kilometers. If we use the precise marathon distance of 26.2 miles, the result is 42.16 kilometers. Our mental estimation using the Fibonacci trick was almost exactly spot on. Why does this work so well? It works because the linearity of the conversion, multiplying by a constant, is mirrored by the linear property of the Fibonacci sequence. Because the ratio between the numbers stays so close to the golden ratio, adding the next numbers in the sequence for each part of the sum is mathematically equivalent to multiplying the whole sum by 1.618. We have successfully applied the decomposition method to a non-trivial distance and verified its high accuracy.
Let's try a few more practice problems to really solidify this in your mind. Suppose you are traveling in Europe and you see a speed limit sign for 130 kilometers per hour. You want to know how fast that is in miles per hour so you can relate it to driving back home. Remember, to go from kilometers to miles, we shift backward in the sequence. First, let's break down 130 into Fibonacci numbers. 89 plus 34 is 123. Adding 5 gets us to 128, and adding 2 gives us exactly 130. Now we shift each one backward. 89 kilometers goes to 55 miles, 34 kilometers goes to 21 miles, 5 kilometers goes to 3 miles, and 2 kilometers goes to 1 mile. So 130 kilometers per hour is approximately 80 miles per hour. Again, the trick gives us a result that is less than 1 mile per hour off. It's incredibly reliable.
You might notice that as the numbers get smaller, the error percentage gets slightly larger. 2 miles to 3 kilometers. 2 times 1.609 is actually 3.218. The error here is about 7%. 89 miles to 144 kilometers. 89 times 1.609 is 143.2. The error here is only 0.5%. The further you go down the sequence, the more accurate the golden ratio approximation becomes, and the more accurate your conversion will be. We have practiced reverse conversion and analyzed the accuracy of the trick across different scales. Now that we have mastered the mechanics, let us take a moment to reflect on why this mathematical coincidence is so special. In school, we are often taught that math is about exactness, but in the real world, the ability to approximate quickly is a superpower. The Fibonacci trick works because it leverages the deep structure of number theory to simplify a decimal multiplication. Let's summarize the process. First, identify the number in miles or kilometers. Second, decompose it into Fibonacci numbers like 1, 2, 3, 5, 8, 13, and so on. Third, shift forward for kilometers or backward for miles. Finally, sum the results. Let's do one final mental challenge together. Imagine a distance of 68 miles. How would you break it down? 68 equals 55 plus 13. 55 and 13 are both Fibonacci numbers. 55 shifts forward to 89. 13 shifts forward to 21. 89 plus 21 equals 110 kilometers. The actual calculation of 68 times 1.609 is 109.4. Our mental estimate was 110. The precision is startling. The next time you are traveling or reading a scientific paper or even just looking at a map, try to spot the Fibonacci numbers. They are not just for nature or art, they are practical tools for understanding the world around us. We have defined the Fibonacci sequence, linked the golden ratio to unit conversion, and mastered mental miles to kilometers conversion. You now have a powerful new trick in your mathematical toolkit. Go ahead and try it out on the distances you see every day.